Number 8 is a good reminder of rational functions. Here you have x equals 8, a equals 8. The value of a is 8. Your function is f of x equals 1 over x minus 8. If you recall, a rational function like this means that there's an asymptote here when the bottom value equals 0. So this is an asymptote at 8. The idea of graphing this function is to see the behavior on the left hand and the right hand side so that you can tell clearly whether it is approaching positive infinity or negative infinity. Because of the size of our graph, I would recommend that we change the scale a little bit so that each box equals 2. That way you can see the values a little bit better and not affect the overall behavior of the function. So 1, 2, 3, 4, 5, that would be negative 10. 1, 2, 3, 4, 5, positive 10. 10, and negative 10. You have an asymptote here at 8, at positive 8. So here's your vertical asymptote. If you recall from trig, when the top function has a smaller degree than the bottom, your horizontal asymptote is at y equals 0. So it's on the axis. Now you have two choices. You can plug in a few values to see where the other branches are, or you can remind yourself that this is a simple rational function. If the top value is positive, then your two branches are in the new quadrant 1 and quadrant 2. Because we're only looking at behavior, you don't really need exact points for these graphs. So as long as you can have a vague idea of what the graph looks like, you should have a good idea of where the limit is going. So your graph should look like this, with one branch going this way and another branch approaching on the left. Now with the graph drawn, you can answer part A, B, and C very easily. Limit as x approaches 8 from the left side of f of x. Coming from the left side, it is heading down to negative infinity. Vice versa, limit as x approaches 8 from the positive side will be approaching positive infinity, is going up towards positive infinity. Now, because the left side is coming down, right side is going up, they will never match each other up. Therefore, for part C, limit as x approaches 8 from both sides will be does not exist. Okay. All right, number 9 does review a bit more of the parent functions, and also what we remind you about is a piecewise function. So for the first piece, you have x cubed. A parent function of x cubed starts at 0, 0, goes up 1, 1. Now it says it is inclusive, so 1, 1 is right here. It's going to curve up, negative 1, curve down, and here's your function. Here's a piece of the function. The second one is a linear function. You can read it as 3 minus x, or you can read it as negative x plus 3. What that tells me is that your y-intercept is at positive 3, 1, 2, 3, and then your slope is negative 1. So down 1, right 1, down 1, right 1. But I only start at the value of x equals 1. So from here, there's my open circle. And you're going to come down 1, right 1, down 1, right 1, down 1, right 1. There's your piecewise function, right? So now with this graph, you can see the behavior of the left hand and the right hand side. So limit, part A, limit as x approaches 1 from the left hand side is going to be the value of positive 1. Coming from the left hand side, it is going to approach the value of y equals 1 right here. Part B, limit as x approaches 1 from the positive side is going to be this open circle here of 2. Right. Again, same result as previous two problems. Because the limits do not match up, the limit at this point actually does not exist. So for part C, limit as x approaches 1 of f of x does not exist.